This is Alexi Karve. I'm going to give a demo today on installing or running MicroShift on the balenaOS. I already have a Raspberry Pi installed over here with balenaOS. So I followed the instructions in this blog and basically uh, installed the balenaOS on the micro SDXC card, and it is available. So what I'm going to do is that I'm going to try to log into that device, but before I can log in, I'm going to scan the device, and once I scan, then I will log into it. Okay, so when I do a scan, you can see now over here, it's looking for the balenaOS devices locally that are available, and you can see, that there is a device, mydevice.local. So what I will do is I will log into that device. I can either log in using the balena ssh mydevice.local command, or I can use the port 2222 to log in. So I'm using the 22,222 port number to log into that particular device. It is currently passwordless, so I just can log in into the device directly. And now if I look at what containers are currently running on this, I can run balena es-a, and we can see right now that there is only the supervisor that is currently executing. There are multiple additional images from the time when I had previously run MicroShift on this device. So if I do balena images, you can see a couple of images that we are currently interested in. This is the MicroShift AIO image. So I'll be running MicroShift using this image. There's another image on top, which is the balenaOS main. This is the image I built locally. So the instructions, if you want to build your AIO image locally, they are present in this blog. You can create this image. We could have used either of these images to run. Okay, but I'm going to use this current second image that is there. What I'm going to do is I'm going to clean up my previous volumes that I had created. So I'm going to first delete this named volume because it contains my previous old data from my existing MicroShift that I had run previously. So if I clean that data, basically it's a fully new machine. Okay, I mean there is going to be no remnants of MicroShift remaining on this particular Balena now. And once this volume is removed, it is clean. I will also go and clean up anything that is in HP volumes. This is where any of the pods that I create or the applications that I execute in MicroShift, this is where it's going to be creating its persistent volumes. So I have cleaned that up. Okay, so if there were any direct folders inside it, they are now cleaned up. I can go and start MicroShift now. So I will run this command now. Instead of balenaOS, what I will do is I will run it using the pre-built image. So this is the image that I'm going to use, MicroShift AIO 4.8.0. It is already downloaded, as you saw in the Balena images. So I'm just going to go and execute it. So now that this container is starting, I can just do balena yes, and we can see that it is up 8 seconds ago. So it has started executing, and it's called MicroShift. Okay, so I'm going to execute inside that container, and we are going to run some particular commands in that. So I'm going to exec into that, and then I will export the kubeconfig file so that I can start watching the nodes and pods. I'll also give the CRI/CTL commands to look at the images and pods as they are created. So let's run this. Okay. So as it is starting, it will take about 3 minutes to start. So while it is starting, we'll see these pods being created, images being downloaded, and then one by one, as the 5 images, 5 pods get created, we'll see MicroShift slowly start up. Once MicroShift is started up, I will be applying a couple of patches because usually I've seen some problems with the DNS and the certificate authority. So once I execute those patches, it will remain stable. So let it start up and then we'll do that. Once it is started, I am planning to show a couple of demos today. One demo is going to be where I'll be capturing certain objects, uh, basically in front of the camera, and if it finds a person, then it will send a message and that particular picture to Node-RED that I have already installed on IBM Cloud. So the IBM Cloud that I have has Node-RED that is currently installed. This is the Node-RED which is currently present, and I also have a chat application that is currently executing over here. So it will send messages to this particular chat application using WebSockets. When it starts sending pictures, it is going to send them to the upload URL, and then it will show it in the image preview. Okay, so that is what is going to happen today. So that will be one of them. There's another demo I have where I will actually install Node-RED on the device itself. So I'll install Node-RED on MicroShift on balenaOS. Okay, so it is going to be within MicroShift that I will install it directly on the Raspberry Pi itself within MicroShift, and that will be the second demo. So these are the two demos that I'll be giving today. Both of them are going to be independent demos. So let's see. It is still in container creating status. So the containers are still being created. Images are being downloaded. What I will do now is I might as well go and apply that particular patch. So let's go and patch the DNS default. And we'll also patch the service CA. So what we are doing right now is we are looking at MicroShift within the Docker container that is currently executing inside balenaOS. What we really want to do is have the ability to directly connect to this device and MicroShift from my Mac directly. Okay, so to do that, what I'm going to do now is I'm going to pick up the kubeconfig file that is there over here and copy it to my device. So to do that, I have some instructions over here. So I already have a Balena MicroShift folder currently on my Mac. I will copy the kubeconfig file to my device and then export kubeconfig that I have copied. And then I'll run one more command, which is the OC alias for OC. That is going to do a skip TLS verify. The reason is because right now the certificate that has been created for MicroShift, it only contains the 10.114.101.2. I have not added the IP address of the main device, which is what I'm connecting to. So I will use the alias for that, and then I will do the sed so that I can change the IP address in the config file, and then we'll connect to it. Okay, so let me quit from that right now. And I will quit from the device. Okay, and now let's copy the config file. I have set the alias, and what I will do is the IP address. If I do ping that particular device, it will give us the IP address of that device. So I have the 209. Okay, so I will change the kubeconfig to point to the 209. And I will do a watch command from here, directly from my laptop now. So I am on my laptop and going to watch the OC get pods. So you can see, okay, that everything is started. MicroShift is running, the DNS, node resolver, certificate authority, everything is currently started and everything is currently functional. So now we can go and run these couple of samples that I had mentioned. So first what I will do is I'll go to the device and go to the object detection. What I have is an object detection YAML file over here. And I've already set it up so that we can connect to the URL, the image upload URL and the WebSocket URL for the Node-RED that I have deployed on IBM Cloud. So I will use those and I will do an OC apply. I'm going to apply this in the default project. So right now, the project is default over here. Okay, and I'm just going to do a OC apply for that object detection.yaml. Okay, so it has gone to running now, and what we should be able to see is that it should be taking images now, and you can see me, right? I can move my hand over here in front, and it should show the hand come up on this one also. So it is executing. I can show a cup probably, and it should detect a cup in my hand. Maybe not. Thinks it's a vase and a cup. Yeah, okay. So it can detect that. So this is the first sample I wanted to show, and you can see right now in the chat application, it's showing the temperature and the bounding box of the person. I will go and delete that now. Okay, so that will get rid of that application. And the next demo that I wanted to show was for the Node-RED. So I'm going to apply the Node-RED.yaml. So I'm going to create a deployment. I will also need to create the persistent volume and the persistent volume claim for this. Okay, so it was pending because the volume was not created. As soon as the volume was created, it went into the container creating state. And even for this Node-RED, I have an image that I have already pre-created. So the image that I have created is Node-RED ARM64, and the Docker file for creating that image is in this folder over here. And if you want to create that, okay, to create that particular image, you just run the shell script that's already present over here with these arguments. So it's going to create it for the ARM64 architecture and the node version, and it's going to use the bullseye slim as the image, and then it will create this thing, and then I push this particular image once it got created. So that's how I created this particular image. So right now it is basically downloading that image, and then once it is downloaded, it will execute it. Okay. So if I do a watch command again, still in container creating status because it is downloading that particular image. Once it finishes downloading, then what we are going to do now is we'll go back to this demo and we will see what the rest of the steps are. So we'll expose this service and get the routes. While it's downloading, I can go and expose the service and get the route. Okay, so this is the route that is currently present. What I will do now is I will update my etc host file. I need to use sudo okay, and now that that has been done, let's watch and see that Node-RED started. Okay, so Node-RED is started now. I can connect to it. So let's connect to the Node-RED. And once it is connected, what I'm going to do is I'm going to copy the flow from here. So I'm going to open it in another tab over here. This is the flow 2 that I'm going to copy. First, let me connect to the Node-RED. I did not start it on port 80. Instead, I had started it on port 8000. Okay, that is the port that I had exposed it on. So that's the port I need to use. So let's go to port 8000 over here. And it is currently HTTP. Okay, so it came to Node-RED. So now that it started Node-RED, what I will do is I'm going to go ahead and import some things. But before importing, there's another thing I need to do, and that is basically come over here and go to Managed Palette and install a couple of things over here. So I need to install the Node-RED dashboard. And then the SenseHat. Okay, so that got installed. Now I'll install the Node-RED Smooth. And then I will go and install the SenseHat. Okay, so that was able to install. So, and now what I will do is I will go ahead and import and deploy. So what we are going to do now is have the SenseHats get the data over here, and then there is a switch which will allow the joystick direction to be displayed on the dashboard, and the temperature, humidity, and pressure also to be retrieved and displayed. If I look at the debug log right now, and I enable the messages, and I look at current flow, you can see the motion. Okay, it is receiving data. Let's just stop it because there is too much of data over here. But what we are really interested in is the temperature, humidity, pressure, and the joystick direction. So what I will do now is I will go and open the dashboard, and there is that link over here. If I go to that particular link, it will open the dashboard. So this is the one that will show the temperature, humidity, and pressure. So let's give it a few minutes until it starts up. basically the joystick direction which is there. If it finds that it gets the label, then it's going to show the label and the value. That is what it's going to do. So when I click the joystick up or down or left or right, that is the label that will get displayed. And for the temperature, if the payload dot temperature is there, it will put that in the payload. For humidity, it will take the payload dot humidity and put that in the payload, and same for pressure. And then it's going to show this gauge where it will display the temperature as a gauge between 0 to 60, and similarly for humidity between, I think, 0 to 100. Yeah, 0 to 100. And then the pressure is 900 to 1100. It is usually around 1000. Let's enable it once more. Yeah, so it has started. So we can see that the temperature is there. We can see the humidity and we can see the pressure. Okay. So this is all I wanted to show for this demo. Thanks for watching.